Good afternoon, everyone. Today we will continue with our embarkment on these webinars related to mainstreaming for industrial revolution for all. And particularly, we will go more deep in one of, in some of the most distinctive technologies that the 4IR has. We will be talking about artificial intelligence, virtual reality, digital twinning, and particularly in one of the sectors where UNIDO is also active, supporting our member states. For this particular session, I will share my screen now to introduce the session. So as I mentioned it before, we will start with the sixth session at this time, focusing on artificial intelligence, virtual reality, and digital twinning in the automotive value chain. I am Alejandro Rivera Rojas, the Executive Officer of the UNIDO Digitalization, Technology, and Agribusiness Directorate, and I will be moderating this third session. Particularly, it's entitled How Artificial Intelligence, Virtual Reality, and Digital Twinning are Redefining the Automotive Industry. For this occasion, we have invited distinguished panelists. We will be having with us Ms. Catherine Hayes, Industry Manager from South Carolina Research Authority. In her current role, Catherine scouts for technology solutions and facilitate technology transfer to support Industry 4.0 and the digital transformation. She also collaborates with various institutions to support industry growth and the mobility infrastructure while fostering the entrepreneurial and innovation ecosystems. We will be having also with us Mr. Luis Ergueja. He is a senior business transformation consultant for Latin America from the South Systems Company. And Luis is responsible for Delmia solutions in Latin America, including collaborative manufacturing, digital manufacturing, and manufacturing operations management. He supports direct sales, teams and partners working together with customers like Grupo Boticario, Ford, Honda, Renault, and others in the automotive value chain. We will be having also on representation of UNIDO, Mr. Alan Baschenheimer. Alan is a national expert on automotive industry in quality, in the Quality Infrastructure System Division, and he is currently working in one of UNIDO projects in Colombia. Alan is consultant and advisor to the minister in the Colombian Ministry of Transportation in the area of automotive technical regulations. The last 4 years, he has been working as National Technical Coordinator and automotive expert for this UNIDO project financed by the Republic of Korea. Today, in this session, we intend, to have a short overview of the automotive industry as a dynamic sector where most of the significant progress and transitions to the 4IR has been happening, in particular artificial intelligence, virtual reality, and digital twinning technologies' relevance for the industry embraces all the aspects of the value chains from the design, production, to autonomous driving. Yeah. This session explores their capacities to assist research and development of products, improve prototyping and design processes, as well as to simulation for factory flows, predict demand trends, provide predictive maintenance alerts, etc., within the value chain. But also the discussion will emphasize on the current trends in developing countries and discuss the challenges and risks for adopting this type of technologies, and where are also the opportunities. our external invited panelists will provide further insights of this potential and the opportunities for these digital technologies in alignment with the UNIDO DTA digital strategy, particularly the outcomes related to harnessing for industrial revolution for economic development. Then, while our colleague, Mr. Alan Bachenheimer, will provide more insights on the work that UNIDO is doing to support the automotive industry in Colombia associated to the adoption of these technologies. We will be having a round of initial presentations as usual, and for each of the panelists, and afterwards there will be a round of questions. Yeah, we will be also encouraging all the attendees to this webinar to post their questions in the questions and answer session, and we will be trying to answer any of them. If not at this stage, later on we will provide the answers by our panelists. For your information, today we are also recording this webinar session, and we will be making it available through our Knowledge Hub platform later on. So anyone that is not able to attend or want to refresh can go again to this. Having said that, I would like to give the floor to our distinguished speakers today. I welcome our first speaker, Ms. Catherine. The floor is yours.
Thank you. It's a pleasure to be here. I appreciate the opportunity provided by UNIDO and this esteemed group of guests. I'm going to do my best to race through some of the key technologies applicable to the automotive industry. And I'll start sharing my screen now. Okay, so I'm, as you heard, I'm the industry manager with the South Carolina Research Authority, and I work with manufacturers across the state and actually externally as well. Just to give you a little context, South Carolina is located about halfway between New York and Florida, so New York City and Miami. We are considered in one of the 8th largest mega regions of the US. So the population growth in the Southeast is really exploding. We have 17 automotive OEMs in the Southeast. In South Carolina specifically, we have Mercedes-Benz vans. We have the only Volvo plant in the United States, and we have the largest BMW plant in the world with 11,000 employees. In the 3-state region of North Carolina, South Carolina, and Georgia, we have over 25 million people, and there is a harbor in Charleston, South Carolina, which is undergoing deepening right now to 52 feet to be able to handle the big ships. The organization I work with is somewhat unique, actually, in the United States. We only know of one other like us, in that we foster and fuel the innovation economy in the state by pulling technology from universities and academic institutions to industrialize and commercialize products. We work with startups and entrepreneurs to foster and fund them, early stage startups up to about 2 million in revenue. And we also, in the area I'm in the Industry Solutions Group, we partner with industry to pilot and develop new technologies to support their digital transformation. I'd like to spend just a minute on best practices. I have the privilege to work with manufacturers across the state, and I've summarized, I guess, their best practices and recommendations for beginning along your digital transformation journey. And keep in mind, this is not something you turn on one day. This is a process, and you need fundamental lean technologies to be successful in it. The key thing to start is to have leadership to define the strategic vision. Are you trying to improve your operations, or are you transforming across your enterprise? It makes it a different approach. We've learned through practice that cross-functional teams are critical to define the digital transformation roadmap, so you get different perspectives from different functional groups. You also need to have them engaged so that they have buy-in into the projects that you're planning. You need both the strategic vision and tactical pilots. The solutions are more cost-effective in smaller pilots. It also helps your people learn And we've had experience with large-scale plant-wide projects. If you start there, you may not realize the results you're looking for. We pilot technologies that drive improved performance, so efficiency, productivity, improve quality, that reduce costs, or deliver value to the customer. It's exciting to go after the cool tech, but that's not the most cost-effective. To scale the new technology, you also need to consider the operational costs and the maintenance costs, the knowledge and the training to implement. It's easy to implement a pilot. It's difficult to scale it. And consider that traditional mindsets, management silos, and outdated metrics may actually obstruct your adoption of new technology. Oops, sorry, I'm struggling here. I borrowed this slide from Bosch, one of our trusted partners, and really one of the experts in digital transformation across the globe. They put together these 5 levels from lean to digital twin, a digital implementation strategy. Again, starting with basic fundamentals of lean processes. If you automate an inefficient process, you're just guaranteed to have inefficiency. In level 1 of your implementation strategy, you're looking at, competence development and computerizing, digitalizing, and connectivity. Level 2, you're looking for real-time information and processing to make actionable decisions. In 3, you're really looking at business intelligence, the predictive analytics, looking at forecasting. In 4, we start getting into the digital twin, so connectivity and interaction of cyber physical systems. In level 5, you have a full digital twin. You have autonomous decision-making and a self-adapting and self-learning system. I want to make a distinction on the digital twin between an operational digital twin and an asset digital twin. For manufacturing, we're talking about an operational digital twin. And that's when you create a dynamic virtual representation of the entire plant. It could be just a process, it could be just a machine, but ultimately you want to do the plant. You get a real-time picture of what's actually happening, not just what you hope is happening. Data becomes actionable, where you can see a real step change in productivity to reduce downtime, predict and prevent problems before they occur. I'm a big fan of exoskeletons, so where we could sensorize this and get data either from that or from a wearable from the actual operator doing the work. So you have real-time information, not just about the equipment, but also about the human activity. But keep in mind, this isn't where you start. Developing and utilizing digital twins is extremely complicated, and it requires vast amounts of real-time streaming data from multiple sources. The only real way to ingest, correlate, and integrate the diverse data sets at scale is using machine learning and AI. Quick definition, artificial intelligence is really the umbrella over machine learning and deep learning. It is the science to build intelligent programs and machines that can solve problems. Machine learning is a technique to realize AI. You take large data sets to train algorithms, and these enable machines to learn and make accurate predictions. So from your real world life, Pandora is using our listening habits to recommend new songs or artists. Waze is considering traffic conditions to suggest a different route to get home. Deep learning is a class or subset of machine learning using neural networks. Again, this uses a very complex system to analyze different factors with a structure that's similar to the human neural system. So Alexa is an example of a deep learning algorithm. And I'll explain briefly a machine vision with deep learning in a bit. So once you've determined your digital strategy, it should really be your customer value that drives your technology choices. Again, it's enticing to get attracted to cool tech. We call it shiny objects, but it's really not the best approach. What we see in our manufacturers, and I want to mention that South Carolina has over 5,000 manufacturers, and over 500 of them are in the automotive industry. We see predictive analytics and AI for process improvement and forecasting to be the #1 kind of request for opportunity and information. Machine vision with deep learning is also a close second, because there's a great opportunity here to augment your human inspection with machine inspection. Augmented reality, mixed reality, and virtual reality, initially just for training, but as you see, as you move along that scale that I showed from Bosch, you'll use virtual reality when displaying the image of your digital twin. 3D printing was once just for prototypes, and now it is definitely in production use, primarily in the aerospace industry for production parts. But in automotive, I heard yesterday in a conference that a company is using it for jigs and fixtures and holding equipment, especially during setup, but then also during full production. Collaborative robots, once robots just were fenced and really, typically large equipment, especially in the automotive industry. But now collaborative robots or cobots are definitely being integrated, not fenced, working alongside a human. Really useful for picking and placing parts, because you can use them with vision, pick the correct part every time. It's rather complex with a takt time of 70 seconds in a vehicle going by to pick the right part. So seeing a robot pick the right part and actually hand it to a human is really effective. I already mentioned exoskeletons. They're passive at the moment, but I'm sure that will change. Automated guided vehicles, also critical. One of the comments I heard yesterday also was about being sure that these are effective in material handling, to make it safer for humans in the plant, and also more streamlined direct routes. And then, of course, wearables. We have several examples of wearables, and one I'll mention was at a plant. Actually, Bosch did it with social distancing. So for COVID-19, they were able to use wristbands and identify when there was an issue where operators and technicians need to be separated further. I'd like to go through just a couple examples that we've seen in our processes and our tech transfer to industry. One example of artificial intelligence was at Rolls-Royce Power Systems. They were able to implement a AI model to predict failure. These fracking engines that are shown here are huge, and it's a catastrophic failure is a lot of money. So there was an incentive there to try to really reduce costs and predict the failure before it happened. I don't have time to go through it, but I'm happy to explain it later. Another one that we had great success with is machine vision with deep learning at JTech to augment human inspection. This is a complex process, and it's very effective. And the third is this augmented reality to virtual reality, typically used right now for training, but as I mentioned, this technology will be scaled and critical for the digital twin. I'd like to wrap up. Thank you very much for the opportunity. I want to mention that we do have grants available to relocate small companies and large companies to South Carolina. We have pilot project grants, and I'm happy to explain how that works.
Excellent. Thank you very much, Catherine, for this very comprehensive presentation and for the challenge of explaining artificial intelligence and complex concepts like machine learning or deep learning in very short time. Yeah. Also, I think as very relevant elements that may be useful for my colleagues here will be to pay attention to this approach that you presented on how to make better use of the strategies, yeah, for digital transformation, particularly on the different examples for the 4IR technologies along the process operations. Thank you very much. We will go now for the presentation of Luis. Yeah, Luis, the floor is yours.
First of all, I'd like, on behalf of Dassault Systems, to thank UNIDO for the opportunity to participate in this event and to share our ideas and experience about how the digital technologies, and especially the ones that Catherine introduced so brilliantly here to us, are changing the automotive industry, right? So first of all, for those of you that don't know us, I'd like to tell you that Dassault Systems has been a catalyst and an enabler of great industrial transformations around the world over the 4 decades of our history. Every decade of our history, we have developed, have helped manufacturers to disrupt how products are designed, made, and to rethink their whole development, production methods. We started in the early 80s as a spin-off of Dassault Aviation. That's the company in our group probably best known. But since then, we moved from 3D product development to full system digital mockups, to PLM, to complete modeling and simulation of full business processes when the value for the companies moved from the product itself for the user experience of the product. And now we are advancing even further, trying to model the life, not only the objects. We are introducing the digital twins of the human body to make possible to simulate and test new medicines, new healthcare devices and procedures and so on. That's the future we envision. And as you can see, we have reinvented ourselves every 10 years. So we have a little experience in disruptive innovation inside our own company. But coming to the point of our conversation today, why is the automotive industry adopting all those nice technologies and many others? Catherine did a great job explaining the core technologies that are the focus of our conversation today. There are many other technologies that we are not going to touch here today, and I am not going to be redundant to Catherine because I would embarrass myself. So I'm not going to talk about the technology, but I'll try to discuss with you why automotive industry is doing that, because as Catherine said, it's not an easy task. Okay, and let's face it, people don't like change. Companies like it even less. So we only take the challenge of big changes like that if we see a huge benefit in doing that, or if we are really forced to do that for survival, right? What's the case here? The Financial Times promotes a big event every year to discuss the future of the car. In the 2018 edition of this event, a lot of interesting things have been said. I will focus in only one for the purpose of our conversation here. The car will no longer be a car. The car will be a robot, a data center, a service, and a digital companion. This is what a car is going to be pretty soon. Okay? Do you think GM, Ford, Volvo are up to the task to develop, produce, support this product? Honestly? So this is a big challenge for them. But if they don't do that, they will be replaced by other companies that can do a better job. So the conclusion from this event, that was only 2 years ago, that are 3 major impacts in the transportation and mobility sector, and I will very briefly talk about each one of those 3, and you will see why the automotive industry is adopting disruptive technologies. First, the number of new companies and new innovation in this domain. I'll talk about one of them. The CIO of this company made that statement that the car is going to be a robot, a data center, and so on. Have you ever heard of NIO before? They started from scratch. They were not a spin-off of a big company. They were a startup in 2016. By now, they have 3 fully different electric models in the market, developed and gone to the market in less than 4 years. Those names here You probably are familiar with some of them, like Tesla. But those are all challengers to the traditional companies. And if you see the type of cars, and not only cars, trucks, vehicles in general, that those guys are doing, many cases from scratch, in many cases, in places, and I was asked to talk about the impact of all that in developing countries. Have you ever heard of Rimac? Rimac develops one of the best high-performance electric cars in the market today. They are based in Croatia, a country with a long-lasting tradition in automotive industry, right? They have never developed or manufacturing a car before, okay? And they have one of the best performing electric vehicles in the market today. That's the kind of opportunity we're talking about. Those guys are, each one of them started from scratch. They started with new disruptive technologies. Otherwise, they could not develop a brand new high performance car in 2 years. The traditional industry has to keep pace with those guys. Otherwise, they will be destroyed by them. Tesla is probably the flagship of those challengers, but it's not the only one. Second big trend, the new car, zero emission, autonomous, and so on, is completely different than the traditional internal combustion engine car. The internal combustion engine car that is started in the 19th century and made the automotive industry the powerhouse of the mass production industry in the 20th century, took about 100 years to get to the point it is today. The electric powertrain did pretty much the same path in 5 years. It's much simpler, less components, used the high state-of-the-art technology. So in 5 years, they got to a maturity level and performance that the internal combustion engine powertrain took 100 years to get. Okay, so that poses challenges but opportunities for companies all over the world, including developing countries. Brazil is there. I am based in Brazil. We are starting to manufacture the first full electric truck in Brazil, a project totally developed by Volkswagen Trucks here in Brazil, and the powertrain is going to be provided by WEG, W-E-G, a Brazilian company that traditionally manufactures electric motors for completely different applications, but an electric motor is an electric motor. If I can do that for other applications, why not for a truck? And that's what they did. In less than 3 years, they developed this electric truck from scratch. They should start production this year because of all the pandemic bullshit. They postponed that for next year, but it's going to happen. Okay? The third trend is the autonomous driving and so on. Okay? But autonomous is the last thing that's going to happen in developing countries, not because of lack of technology or ability to develop that. I was talking to Leonardo, the COO of ThyssenKrupp Equipment for Mining. They have developed in Brazil a stock reclaimer, huge equipment for ports and mining stockyards and all that. Full autonomous. They have developed that in Brazil. The problem with the autonomous car in developing countries is the infrastructure. The thing is, an autonomous car is a computer, is a robot, and it requires model-based systems engineering. It's more like developing a very complex electronic system with a lot of embedded software and mechatronics, because the mechanical part of that car is going to be a piece of cake. The difficult piece is all that here. Okay, the systems engineering behind this car is going to be much more complex than anything else, and that's what's going to make the difference. Okay, uh, just to make my story short, this is going to be a revolution in this industry, full of challenges and full of opportunities. The thing is, if we as developing countries, and I count in because I am in Brazil and I cover Latin America, if we don't jump in and take our share, we are an endangered species in this ecosystem. Okay, for you interested in a little more information about that, I recommend those two links. And the most interesting link to show how this is changing, the most interesting site I have found to discover the trends in the automotive industry was in the Consumer Electronics Show 2020. Okay, better than any automotive show, Consumer Electronics Show had the most advanced mobility companies showing the new products and the new trends this year. And that's where I will recommend you to go if you want to see what's going to be the car of the future. So thanks for your attention. I am stopping my sharing here and giving it back to you, Alejandro.
Thank you very much, Luis, for this very passionate and motivating presentation from your side. I think it's very important for us to understand all these elements that you were mentioning, and particularly on the definitions that are given for a car, yeah, as a future object, yeah, that we all need to think about it, how to change even, I mean, more on the core and not on the that I am used to do cars, but what is the purpose of these cars? Yeah, so
I can't wait to get one of those in my garage.
exactly. Okay, and particularly, I think it's very important what you mentioned, that there are some opportunities for newcomers and for developing countries to be inserted in these global value chains that are at this stage are being embraced by innovation and by technology adoption from the 4IR and other possibilities. Thank you very much. I will pass the floor now to our last panelist, Alan. The floor is yours.
Thanks, Alejandro. So I will share my screen and then start the presentation. So thank you so much for having me here. I'm really glad and honored to present what we're doing here in Colombia to my other colleagues at UNIDO. So, well, I hope this experience that we are having right now on having applications for the fourth industrial revolution technologies will also work for you in your projects that you are now developing in different countries in the world. So, well, we are working, and I'm going to make a short overview of what we are doing and our project in Colombia. We are working on a project called Promotion. It's a technical cooperation project, and we are looking to improve the competitiveness and quality of the Colombian automotive and mobility industry. Of course, it's executed by us, by UNIDO in Colombia. Of course, we also have some colleagues in Vienna supporting all the development of the project. And we are using resources from the Korea International Cooperation Agency called COICA. The recipient of this is the Colombian government through its industrial productivity agency called Colombia Productiva. And of course, the beneficiaries are the Colombian industry, all the value chain. So who are those companies, the beneficiaries? They are final manufacturers of vehicles and all the suppliers below them. So we are working directly with land vehicles that have wheels and goes on land. So we have some manufacturers here in Colombia. Big ones are GM and Renault, also Hino that does trucks from the Toyota group. Also, we have a lot of motorcycle manufacturers in the country, mostly from India and Japan, and some different body bus builders, ambulances builders, and so on. Those manufacture final vehicles. Below them, we have around 126 tier 1 suppliers, some other 156 lower tier suppliers. and 77 companies that does aftermarket products. From all that companies, we think on the supplier side, we think that just 10 or 15 are ready to implement some 4th Industrial Revolution application. So I'm going to explain you a little bit what we have done in Colombia with these companies to try to get closer to this. So what we have done to have an adoption of 4 IR-based applications in the country. We have followed, let's say, 6 steps. And like I say, most of the companies, we think they are not prepared. So we have a few ones that are prepared. So, but we started this like 2 years ago. The first thing that we do was to partner up with local institutions that promote the 4 IR technologies adoption. And we have some government ones, some mixed ones, and all of them have been really great partners for us. For example, the National Planning Department is now working on doing the policies for the 4th Industrial Revolution adoption. So we are working with them, helping them to define the roadmap of Colombia on this aspect, and this is really, really important. And the other different institutions are also working on different types of things to support Colombian adoption on these technologies. And then what we did, of course, was to know what we have in the industry. You know, from these 300 and something companies, we needed to know the knowledge they had about this industry. I mean, what do you know about for the 4th Industrial Revolutions? What you can do with that? And we asked that type of questions, and also we assessed the adoption state of these technologies. So we made some surveys to most of the companies, interviews, meetings, and we found out that that most of them knew, hear about it, but didn't know actually what it was, and also what to do with these technologies, and of course which applications works for them based on these technologies. Having those results, we define an academic agenda to fill the knowledge gaps. So we have been working on that the last 1.5 years. It's really important for us and for the application that people know exactly what to do and how to apply or solutions based on those technologies. So we had 2 participations in the Hannover Messe the last 2 years. Actually, I met Luis, I think, in 2018 there. We also had and still having some sessions with the National Planning Department to help them to build the public policy for the 4th Industrial Revolution. And we had a session also regarding 4th Industrial Revolution policies in emerging economies, also with them and with some other stakeholders. And we have done so far 10 events. Last year were in-person events. This year has been online events about application cases. We needed to explain the companies with cases how you will be benefit on applying 4th Industrial Revolution technologies solutions in your companies, and then we just went through different type of cases, the most common ones, and some of them Catherine just explained it to us. So they have, I think so far most of them have a really good idea of how I can apply this in my company and what will be the benefits for me. In parallel, we also just didn't want it to make academic sessions, but we also wanted to make some applications about this during the project. So we also make some surveys and interviews with the companies, and we wanted to identify the most needed problem or challenge that can be solved or accomplished with 4 IR-based applications. And we found out that the most needed application or solution they needed was to identify quality problems in early production stages, to reduce the cost related to guarantees, reworks, client returns, and of course to increase the process efficiency and client satisfaction. Of course, all this using applications based on 4 IR technologies. So we define a challenge with Ruta N, that is a partner here in Colombia. They are promoting innovation and different these subjects for IR applications. And we launched a challenge with them in a platform called Sun to companies, automotive companies. We received like 10 applications from automotive companies that wanted to get involved on this small project. And also we received like 12 proposals from solution implementers here from Colombia. They already work with this type of solutions. So actually, we early saw what we are doing here. This is a machine vision with deep learning, actually, you know, what Catherine just explained to us just a minute before. So to identify quality problems in early production stages, what the proposal actually have, let's say, 4 steps. And the first one is to have an inspection using sensors. Most of them will be high-speed cameras because we wanted to check the finish of the surface of the products. And then this information is transmitted and analyzed and compared with predefined quality parameters in real time. If there's a problem in the one-by-one real-time inspection, there's an alert of non-conformities, and of course that the machine says to the managers that there's a problem, and also some actuators who can reject automatically the defective part just to checking. Then after that, the results information is stored and processed for algorithm retraining and process improvement. So this is actually, well, what we saw earlier, you know, with deep learning. Maybe you haven't seen here any of 4 industrial revolution technologies on this slide. Anyhow, this is working on the back. And this is what we are trying to tell to the companies. Most of them are solutions for you, real solutions, real life solutions. Anyhow, in the background, a lot of these technologies are working behind. So sometimes it's a work of different 4IR technologies working together to have a solution. Sometimes there's one, but for example, on this application, we have at least 6 possible 4IR technologies working behind all this in this solution. We have IoT, Internet of Things. We have artificial vision, cloud computer, system integrations, data analytic, and machine learning. That is, as we saw earlier, a sub-branch of the artificial intelligence. So we are now with the companies and negotiating how to implement this. We have the solution just ready. We are just trying to have a general solution that can apply for most of the companies that are here, that are on this project, and to have different small changes to have one application for different type of products. So, well, this is what we have done so far in Colombia regarding this subject. It's a big step for us. We know this is the first time for all the automotive industry. They have start implementing this type of solution. They have not do that. We know all of them. We have talked about this with all of them. And this is a great big step for us. So if you have any question about these steps, or to know more about the problems we had during this process, and maybe you want to know more in your projects, the projects you are working in your countries, please just send me an email, and I will be happy to help you on that and give you my point of view. Okay, thank you so much.
Thank you very much, Alan, for giving us this overview on the Colombian automotive and mobility industry, and also for presenting us some of the actions that the project is supporting. Particularly, I see you touch one of the challenges that we see for the use of artificial intelligence regarding machine-human interaction, and how we need to learn. I mean, to do what the machine is asking us to do. This is one of the main challenges related to that. Okay, thank you very much. I appreciate all the presentations that you have shared to us. Then we will start with the round of questions. The first question is for Catherine. Catherine, Can the adoption of advanced technologies in the automotive industry impact the participation of developing countries in global value chains? And how can small and medium-sized enterprises producing automobile components in these countries keep pace and remain competitive and responsive?
Okay, so those are two big questions, but I would say on the first question, absolutely, they can and should participate. Although we have a number of, tier ones, the tier 2 and tier 3 really make up the majority of the automotive supply chain. And some of those companies are 20 persons or less. So I think there's absolutely an opportunity. I know in the United States, the original equipment manufacturers have specific, I don't know that they're financial incentives, but they have purchasing that's looking at working with diverse suppliers and to help them along in terms of qualification. BMW started a program about 5 years ago with 50 suppliers, and the event they did last year had 2,200 people at it. So it's a real commitment from some of the OEMs to have diversity from around the globe. So yes, there's definitely an opportunity there. And not to be too repetitive, but I would say, how do you engage? I mean, everyone knows in the automotive industry, quality is the #1 piece. So you have to be able to make a quality product. And in terms of using advanced technologies, like we've already talked about, start small, have a vision for where you're going to scale, but start small and practice and learn and see what goes wrong and learn from your mistakes as well as from your successes. We have a statistic in the US that over 50% of the pilots are never scaled. That's a waste of money. So, if you're going to engage in this, be all in, that you're going to learn the technology and see where it applies. And I think one of the things Alan showed, and also Luis, is this can be duplicated in multiple places in your plant, across your country. You don't have to invent the wheel every time, like copy and paste. So I would say, and the last thing I would say is that, again, make sure you have a strategic plan before you start. You can waste a lot of time and a lot of money putzing around or playing around with technology.
Okay, thank you very much. The next question is with Luis. Luis, from a strategic point of view, what policies and regulations are needed for enabling a smooth digital transformation of the automotive sector? And how can standards support innovation in the automotive industry?
Well, again, two big questions. I'll separate the two. And I would like to start saying that I honestly don't believe in a smooth digital transformation, because after all, this is an industrial revolution, right? I never heard of a smooth revolution. So if anyone is expecting a revolution to get smooth, I'm afraid you are going to be disappointed. There's going to be bumps. There's going to be struggles. There's going to be losses on the way. At the end, what we all hope is the outcome of the revolution is getting us to a better environment, to a better position than we are at the beginning, but it's not going to be smooth. And there are many reasons for that. We could spend a lot of time discussing that, but just to give one quick idea, a traditional industrial combustion engine vehicle has more than 30,000 parts. 2,000 of them are in the engine itself. An electric engine has 20 moving parts. Okay, the supply chain for the automotive industry is going to collapse and reduce, and the companies that are not prepared for that will disappear. I have a conversation with Mauricio Muramoto, who is the innovation director of Sindipeças in Brazil. Sindipeças is the federation of the auto parts suppliers in Brazil. He's extremely concerned about that, because the companies that are not prepared to make this transition will not be here in 5-10 years. Okay, so it's not going to be smooth. Okay, but it can be a manageable process. Okay, with that said, let's split the question in the two pieces it has. Okay, policies and regulations are not going to enable the transition, but they are already driving the transition. Okay, why is everybody going to electric cars? One of the major reasons is because the environment regulations all over the world, especially in Europe. This year, 2020, Europe is starting to enforce the famous 95 regulation, right? Any car sold in Europe starting this year that issues more than 95 grams of CO2 per kilometer will incur a penalty of 95 euros for the manufacturer. Okay, the 95-95 rule that has driven the efficiency improvement of industrial combustion engines and the electrification and the search of other alternative zero emission powertrain options in the industry. That is a regulation that has a tremendous impact in the digital transformation happening, that's causing companies accelerate the developing of new alternatives. And as long as the world keeps enforcing this kind of regulation, this will drive the evolution of the industry. That's one thing. Okay, but it's not facilitating, it's the other way around. It's pushing, it's driving, it's enforcing the transformation. Because if we make it easy, everybody goes back to the comfort zone. Nobody likes to change. Okay, okay. To your second question about how standards can support that, this is an important point. It's not going to be smooth, but it doesn't have to be hell. We don't have to reinvent the wheel, okay? And companies can cooperate with standard bodies to make things a little easier. The automotive industry has done some interesting progress in that area. The Global Automotive Advisory Group that embraces many of the big names, so Daimler, Ford, FCA, Volkswagen, Volvo. So they are working, and I'm talking here mostly about that last point of my presentation, the car as a complex system with electronics, mechatronics, software, and so on. That's the piece the company really doesn't handle well. How to make it better, okay? They are adopting several standards like AUTOSAR for the software development and reuse in the car. The embedded software in a car is a very critical piece of a car today, okay? Everything in a car today is electronic. When you hit the brake, you are only sure that your car will stop because some software acts on all the components to make it brake properly. If this software crashes, your car doesn't brake, okay? Or not properly. So software is an incredibly important component. There are standards for software development and reusability in automotive. We talk a lot about digital twins and models and all that, but if you develop your components of your functional mock-up of your car in different tools with different software, different technologies, how do you integrate all that? Okay, there is this functional mock-up interface that's also a standard that has been embraced by this Global Automotive Advisory Group to try to facilitate different companies using different tools to put those pieces together. So there are efforts in standardization that will facilitate and accelerate the process. Unfortunately, it's not going to be that smooth. It's going to be a revolution. It's not going to be a walk in the park. But we have to face that because it's going to be inevitable. I don't know if I answered your question, but it's the best I can do.
Thank you for sharing these views. I think it's very relevant and pertinent. Yeah. For reasons of the time, and not to continue this. I mean, on this topic, I think it's very relevant, and standards can play really a role. This is our understanding from UNIDO side. I will pass now to the question to Alan. Yeah, Alan, what are the most important lessons learned from the implementation of digital technologies among the Colombian automotive companies so far? Yeah, and how can the Colombian SMEs in the automotive industry be supported in mobilizing the investment needed for this digital transformation?
We found, let's say, those main lesson learned on the application we have done so far, and is that, well, it's just one, but it's divided in two. They have to be prepared. I mean, companies must be prepared. We have rejected some companies because of they are not prepared. They have to have a deep knowledge of their processes and the production line. They have to have acceptance and rejections criteria. They have to count with technified processes and effective production methodologies. That means lean manufacturing. I think Catherine was telling that in this Bosch presentation. They have to have some type of statistical data also. It is needed. So not all of the companies are on that point. Actually, like I say at the beginning of my presentation, out of the 300 companies, I think 10 or 15 companies are actually there here in the country. So we have to work with the other 200 and something to get there in order to jump to apply properly these applications based on the four industrial revolution technologies. So first, company has to be prepared, and second, people has to be prepared also, and it is really important. I do remember in a presentation that we had on those in the academic agenda. It was a professor from Germany, from the TU Technical University of Berlin, and his last slide said that to be successful applying this to the industry, it was like 70% people and 30% technology. So we need the managers committed. They have to understand the benefits, and also the people that we apply has to be trained, also well trained, and understands what they are doing to have a successful application. So this is something that we learn. It is not just a turnkey. You know, you need first to be prepared and then to apply to have some benefits. Instead, you won't have any benefit on this, and you will just spend money. And for your second question, how the Colombian companies can be supported to mobilizing the investment needed, the government is key. And they have to define public policies, at least in our countries, to create tools to facilitate the companies to get the investment needed. So thankfully, here in Colombia, the government knows that, and they are actually working, as I say, the National Planning Department are working on the public policies, defining tools and the way they will support the companies to jump into this. So this is something really important. You know, if the government is not working and letting the space ready for the companies and the tools ready to finance the companies, I think it will be hard, because we also found that on their own they won't do that. Maybe because it's needed or as a last option, but if it is easy facilitated by the government, it will be easier mobilizing the investment needed for the digital transformation.
Thank you, Alan. Yeah, I will continue with one question for Catherine. Catherine, for the adoption of these advanced technologies like artificial intelligence or others, new skill sets are needed. Yeah, how can government support institutions and the business sector reboot the learning system to skill and reskill the workforce in the automotive sector?
It's a great question, and I think going on with what Alan just said, that the people piece, the tech is easy compared to the technical skill set needed and the adoption. So in the US, I can tell you that we have, the Obama administration actually started this, and Trump continued it. It's called Manufacturing USA. there are 14 centers set up across the United States specific to technologies. So some might want, the first was 3D printing. There's others on IoT. It kind of continues across the US. There's centers of excellence that are public-private partnerships between industry and academia, and including technical college systems. So the tech college system in South Carolina is extensive. We recognize back, you don't know our history, but we were very successful with textiles, but we lost that in the 80s and 90s. And so we had to reskill. We had a lot of people without any training in anything else. So we have a very extensive technical college system that is directly connected to industry to be providing curriculum and training for a 2-year degree for students to be able to work in manufacturing primarily. We also have a really interesting, I'm happy to share this, a nationally acclaimed apprenticeship program. So we modeled it from the German apprenticeship program. We started this, I don't know, probably 15 years ago. And now we have a youth apprenticeship program. So you can be in your last 2 years of high school and go to a factory during the day and take classes during the day. And after 2 years, then typically you're hired by them and they'll continue with your apprenticeship while you go to a technical college and continue working. So it really helps from a financial standpoint, say, you know, the lower income families, and it gives them a skill set. And these folks are making over $50,000 a year. So it's a worthwhile opportunity. The universities partner with industry. That's one of the things my organization does. We specifically help pull technology that's applied to industry. We help the funding for that research. And we know that we have an industry partner that will use that application once it's developed. And then I think the last thing is that maybe Alan and Louise touched on this. You need a strategy and a dedication to make this happen. Louise made a really valid point. The supply chain is going to shrink. Businesses are going to go out of business if they don't prepare. And your workforce is probably the most critical piece of it.
Yeah, Louise, considering this last comment from Catherine. Yeah. What are the main differences in digital technology adoption across actors in the automotive industry value chain? Yeah. And what are the most daunting challenges they face when adopting digital technologies such as the ones that we were talking today?
I really want to follow on the path that Alan and Catherine started with, that thing of the strategy and so on. The most daunting challenge is to define the strategy. What do you want to do about all that's happening? Because it's not about the technology. I would say it's not even about how you are going to reskill your people. It's about what you want to achieve with this technology and these people. And that's what I am feeling is missing for most companies. Okay, and I will dare to make a statement, and don't take that as an official Dassault position or anything. It's just me. Okay, I believe, and since we are talking mostly about developing countries and probably most about the tier companies, because the big OEMs, they have their strategies. And probably they're not going to disappear. They are going to reinvent themselves. They have enough money and they have enough brains to define a new strategy and reinvent themselves. Most of them are doing that. I am much more concerned about the tiers, okay, because they're not going to be 5 tiers anymore. The thing is, I believe the industry will change. It's not going to happen overnight, and there are going to be 2 types of opportunities for companies. A short-term opportunity that's going to be to keep providing for the traditional business that will not going to disappear overnight. And it's already happening. Okay, I was talking to a guy here in Brazil. He's a plant manager for a multinational company. He is increasing his production volume and he's selling like he's never done before, because no other plant in the world wants to continue to produce components for diesel engines. Everybody wants to go do something else, new stuff, electric, hydrogen cell, whatever. Nobody wants to continue doing components for diesel engines that everybody believes will be dead at some point in the near future. So they are moving all the production of those components for this plant in Brazil, and the guy is producing record levels month over month. This year is a little different, okay? But he was making a lot of money, he was growing, he was investing, and he is smart enough to take part of this additional volume he's making with a product that nobody wants to continue investing, and separating part of this additional margin he's making to invest in something new and trying to reinvent himself, okay? But there is an opportunity for the traditional tiers to capture this business that's going to be there for a while, that a lot of people is trying to push back. No, I don't want to do that anymore. It's old tech. It's low margins, but it's going to continue to be there for I don't know how long. If not as a mainstream supply to the OEMs, at least as spare parts. So there's going to be a market for that can be explored. But I don't think it's a very smart strategic move to rely only on that. And then there is the opportunity to introduce the company in the new supply chains that are being defined as we speak. Today, a lot of the companies, those bunch of small ones that I mentioned in my presentation, and even the big ones developing the cars of the future, they are doing that as small startups inside the big organizations, very verticalized, trying to reduce the number of departments because they are learning how to do those cars of the future. You don't want to learn with a sixth level supply chain of a lot of people that are also learning, because it adds too much complexity and uncertainty in a process that's not well established. Try to introduce yourself in one of those supply chains, as the engine manufacturer here in Brazil did with Volkswagen for the electric truck. Okay, because those supply chains are being built as we speak, and that's a unique opportunity, because the traditional vendors in the traditional supply chains may be displaced by new challengers if you prove competency and agility and resilience. Okay, everybody learned this year that the global supply chains we used to have are not the best thing since sliced bread, right? So everybody's rethinking those global supply chains the way they were, and a lot of things are going to change starting next year. So there is an opportunity for companies all over the world to claim a new position in these new global supply chains that are probably not going to be so dominated by China and Asia anymore. That's what I hope. And so it's going to be a new game. Okay, they are just given the cards. Get a place on the table, get your cards, and play it.
Okay, thank you very much, Luis. Always very passionate in your answers. Okay, we have one more question for Alan. I think this one is a challenging one as well. The automotive industry is showing little progress in gender diversity, with women making up only 16% of the industry. What roadblocks do women in the automotive sector face? Yeah, and how can advanced technologies help to promote gender equality and create more gender diverse workforce in the sector?
Okay, yeah. No, actually, I had a little support on this one. You know, I have some support from colleagues that are actually working in the promotion project on this gender diversity. So let me tell you that maybe in the industry, just the 60% of the women are women. But actually here in Colombia, the woman represents the 25% of the employees. So this is, let's say, good news. We are better than the average. Anyhow, it still needs more. We need to get better inclusion of women in this industry. We identify that women in the industry are more on administrative positions and also on motricity work, I mean packaging, assembly, harnesses, or something, that kind of stuff, at least in Colombia. And the tasks that requires physical effort are more done by men. So this is what we have now in the country. There are some, of course, roadblocks that women are facing here in this industry, and some of them are the myth that exists right now. Like, for example, woman cannot do this type of work because it requires some physical effort, or men have always worked on this sector and women don't like it. You know, they prefer some different sectors. Those are just myths. Also, we also found that companies open calls for applications for both men and women, and we just receive, or the companies just receive or don't receive CVs from women, just men. So there's also an obstacle created in the general mindset that doesn't encourage women to train or to apply them on these areas. So what we can do, yeah, Luis?
Please finish. I just want to add a comment to your answer when you're done.
Okay, so what we can do also with these advanced technologies to promote the gender equality. Well, first we need to promote the training of women, of course, in these areas, so they can compete in the job offer. So, and also there's an advantage of this new transformation of the industry, because this industry is not like requires, let's say, physical effort that actually, you know, is something that is changing in the industry, and this is something from the last century. So these advanced technologies applications can also change this mindset that this industry is just metal mechanic, just for men, just like a tough industry. And then we can also just promoting the training of women and applying to this, and also with these changes we can maybe have more women attracted to apply also, because it's not just because we don't receive, or the company doesn't receive women, it's because they also don't apply. It's something on, like I said, in general mindset, so we need to start there. Okay, Luis, you were going to say something or complement something?
Yes, I fully agree with you, Alan. I just want to make one comment, and I will send in the chat later a link. There is a video on YouTube from Scania, one of our customers, that shows the assembly of a gearbox. The video is called "A Gearbox is Made" or something, or how a gearbox is made. I will send the link later. That shows, I believe, an equal number of men and women working on the assembly of the gearbox. And if you look at that, you'll see that it's very clear that anyone can do that, because the process is done to ergonomically not hurt anyone. Okay, the devices, the automation, the ergonomy of the process, the plant, is done in such a way that, being totally politically incorrect, even a child could do that. Okay, so the thing is to apply the technology, to apply ergonomics included, to make the process human fit. Human, not men or women. So be gender agnostic about that. If you do a good ergonomic process, anyone can do that, and that is a first step, in my opinion. Not the first, but one important step in that direction.
I want to just throw in that one of the things we see is that technology is kind of an equalizer, not just women, men, but also color, rural versus metropolitan. So we're looking at having technology development and entrepreneurship in rural communities so that they don't rely on a big factory coming to town to have a source of income. And I think that's something that's really applicable for developing countries. It does take some infrastructure. Typically, it takes broadband to have access to the internet, but the technology can be developed. The things that Louise was talking about, that's not gender-based. That is just your head. That's, study and research. So.
Yeah, it's a mindset that we need to change, and also it relates also to some cultural behaviors. But I think most emphasis should be put on preparing. Women on skills, on the new opportunities that these technologies can bring. Yeah, for them to join not only. The shop floor perhaps, but in the other parts of the value chain. Yeah, I think there is a lot of opportunities for them to join and to provide, better efforts in the entire support. Okay, thank you.
Quick comment. I'm moderating a panel this afternoon that's pre-recorded. I can send you a link if you want to send it out, and it's with 4 women in industry talking about technology and automation. 2 are entrepreneurs and 2 work in major companies.
This is excellent. In UNIDO, we have also this, this program on women empowerment, particularly related to innovation and to 4IR. We organized this event a few months ago. And our colleagues, even from the agro department, has been doing a lot of work on this endeavor. But particularly the entire organization is more focusing on how to boost this gender empowerment along the value chains that we are working. Thank you. I just want to take the opportunity to take one question that I think from the questions and answers session, I think we can address it. Yeah, we have a little time for that one. I just will select one for the attendees to this seminar. I will encourage you to wait a little bit. We will be sending you the answers of all your questions later on. Yeah, we have collected all of them, and we will be sharing the answers provided by our panelists to you later on. I have only one question here that I think is also important. And the question is, what are the greatest challenges in terms of data security? Yeah, for example, for vehicle owners or drivers in the case of new generations of vehicles, and what are the related risks for individuals? Yeah, this is the question. I don't know which one of you want to address it? Yeah, maybe Luis.
Oh, I can take that. Data security is a concern to all of us in all industries in our daily lives. So I am concerned about what's happening here. So right now, what's happening as my children are having remote classes during the pandemic, and I don't know exactly what they are watching in their computers or iPads between classes. So data security is a concern, period. Okay. When we start embedding more and more technology in our industrial processes and in our vehicles and all that, it becomes an even more daunting concern because, and I want to point to just one aspect of that. I talked about the amount of software and technology and algorithms that are going to be inside a car. Okay, an autonomous car is a fantastic piece of technology and a very scary one. If you imagine you are backwards to the road talking to your family while the car is driving, and it has to make its own decision if it hits a bus or hits a group of children on the sideway in case of an emergency, and the software is going to make this decision, and this software can be tampered by a hacker or whatever, it's a damn scary thing. Okay, damn scary thing. And on the other hand, when you think that nobody wants the software in its car to be totally closed, you want to download your applications to your car as you do here, right? I bought a car from a colleague. A French colleague was hitting back to France, and he sold me his car, and I love the car. My wife hates the car. Why? Because the Wi-Fi connection is poor, and she cannot replicate her iPhone properly on this car, and she hates it. She wants to sell the car and buy another one because she cannot use the nice applications she has in her iPhone when she's driving. Okay, so we need to find ways to make the products we use in our daily lives open, flexible, user-friendly, and at the same time safe. There's no easy way to do that, as far as I know. It's one of the biggest challenges of our time. Okay, I don't have an easy answer for that. If any one of you guys has it, please jump in and help me here. I don't think there is an answer for that today. I don't believe there will be an answer for that anytime, because as we evolve the technology to make things safer, the other side will also evolving to hack into that and make things difficult for everybody. It's a catch-up game over and over. The thing is, we want to make sure everything is as safe as possible, and the benefit is much higher than the risk. That's the name of the game. So we all know we are at risk when we put our daily life information here. Why do we do that? Because we believe it's worse, right? So I think that's the trade-off we are all going to make. The more we have at stake, when we have the life of our children at stake, we take it more seriously. And but that's it. So it's always a trade-off between benefit, risk, and it's part of our job as a technology company to make everything we do and the products we help our customers develop as safe as possible. It's never going to be 100% perfect, but we have to make it as safe as possible to make the benefit worse, the risk minimum, and get everybody confident enough to keep the revolution moving. That's my
Thank you.
view.
Thank you. Thank you very much, Luis. I want to thank all of you, Catherine, Alan as well, yeah, for providing us with all these nice pictures and the presentation you have shared, particularly for sharing us also your views on these top questions that we have posed for you. Thank you very much. We really appreciate all the effort and the time that you have dedicated for this. Just for the general audience, I will remind that all the questions will be also addressed later on by our panelists. Yeah, we will be sending you this in a separate file. Also, I would like to take the opportunity to invite all of you to attend the next webinar that we are planning. It will be focusing on quality infrastructure 4.0, which is, I understand, is very related to the last part of our discussion. And with that in mind, we are ready to close the session. Yeah, I thank you again, all of you, for being there, being here with us. Yeah, and we look forward for working with all of you in implementing this digital transformation strategy, and particularly for supporting developing countries. Thank you very much.